for homework. You guys have, I think, did I put a bunch of, go to the very back of your packet? You got a lot of scrap graph paper, a sheet of scrap graph paper, a couple sheets, right? Okay, so if you ever need to graph during homework, there's no excuse why I didn't have graph paper to graph. All right, and I'll talk more about that when we get to it. All right, here we go. Let's fill in a couple blanks here. When I do a transformation, and when I say, let's make sure we're all on the same page. When I say the word transformation, I'm talking about rotations, what we're going to do today, which is reflections, a translation, which is like I slide it up, down, left, right, diagonally. So this is what I'm talking about when I talk about transformation. So anytime you hear the word transformations, I'm doing something to the figure. I'm moving it. Maybe I'm changing its size, making it bigger or smaller, but I'm also moving it around. If my original figure okay, whoa, I don't need that many. Okay, let's say I take my original figure, I move it around, maybe I turn it. If the two at the end are congruent to each other, meaning same size, same shape, same size, same shape, if they are congruent to each other, we refer to that as a rigid motion. Okay. So whatever I did here, turned it, slide it, whatever, if the two end up being congruent at the end, I performed a rigid motion. Okay? Rigid, that's a term we're going to use throughout this unit, a rigid motion, if the two at the end are congruent. Now, you probably did one in the middle school where the two wouldn't be congruent at the end. What's that one called when I blow it up or shrink it? Anybody remember what that was called? A dilation. Okay, so a dilation is not a rigid motion because it changes the size and shape, or changes the size. But a dilation does preserve angle measure. So the only one we got to worry about is a dilation, which is not a rigid motion, right? Because it changes the size. Last thing, as far as notation vocabulary-wise, the figure we start with. It might be a triangle, might be a quadrilateral, who knows? But whatever figure we start with, that's called your pre-image. Pre-image, that's the figure I start with. Then I do something to it. I blow it up, I rotate it, I reflect it, I translate it. Whatever figure I end up with, that's my image. So I start with a pre-image, and I end up with an image. So I have two quick examples down below. Does the transformation that happened, does that look like to be a rigid motion, meaning the original is congruent to the image? So I had this triangle here on the left. Looks like I did something and moved it over here. I shrunk it and I moved it to the right. Does that look like I performed a rigid motion? Is the original and the image congruent to each other? Does it look congruent to each other? Just a yes or no. Do this. The original and the image look congruent to each other. I don't even want to change the number. Whoa. I don't even want it. I'm just rocking it. Oh, right off the bat, 11. Do they look congruent? Nope. Not a rigid motion. Whatever. I don't know what happened, but it's not a rigid motion. Because a rigid motion would result in the two figures being congruent to each other at the end. And what about my next pair here, number 2? Does that look like a rigid motion was performed from this figure to this one? All right, my patience is only so far. 7? Yeah, rigid motion. What happens results in a congruent figure. All right, so we're going to talk about one of these rigid motions today, which is a reflection. We're going to flip stuff today. All right, we're going to flip stuff. Notation, because I don't want to write the word reflection. You don't want to write the word reflection all the time. We're going to do a lowercase r. Okay, lowercase r represents a reflection. I'm doing a reflection. And then you will see something written below. I don't know, have you ever heard of the term subscript? Subscript, does that sound familiar? Not in math, but just in general, subscript. You will see something down here that tells you the line we're going to reflect over. So again, the R tells me reflection. You're about to do a reflection. Then down here tells you the line to reflect over. And well, this is the topic today. How do I reflect something over a line? Okay, here we go. We're just going to jump right into it. This unit does do a lot of graphing. So I gave you a little piece of graph here. We're going to take point A, 2, -1. So can everyone go on that graph and graph at point A, 2, -1 for me. Over 2, down 1, call it point A. Call it point A for me. Two, -1. All right, first thing, here we go. First reflection. Everyone see my lowercase r I talked about. And then everyone see the subscript. This tells me take point A and reflect it over the x-axis. Over the x-axis. Here we go. When I reflect, distance does not change. I'm going to do it over the x-axis. How far is point A away from the x-axis right now? Just count it. How far is point A away from the x-axis? How many units? 12? 1 unit. So that means I go 1 unit in the opposite direction. 1 unit in the opposite direction. Here's my new point after being reflected in the x-axis. Now, I can't call that point A anymore. Here's point A. Anybody remember your middle school days, how when I reflect, rotate, translate something, what I called the new point? Lowercase a. No, not lowercase a. I'm still going to call it A, but with prime. It's called A prime. All right, that means something happened to that point, A prime. All right, so go over here. A becomes A prime, and now somebody tell me what my new coordinate is. When I reflected it over the x-axis, what did A become? What is that new point? 12 again? 2, 1 now. Yep. So when I reflected over the x-axis, it became 2, 1. Distance does not change. Count, and then go that same distance on the opposite side. All right, let's go here. A now, right below. We're going below, not to the right. We're going below. Still take 2, -1, but now reflected over the y-axis. So go back to original point A. And now I want you to reflect it over the y-axis. So distance doesn't change. How many units away is A from the y-axis? 8. How many units away? 2. So everyone, 1, 2. Go 2 units in the opposite direction. 1, 2. And I'm still calling this A prime. I wouldn't go double. When I go double prime, that means I did something to A prime. Then I would call it double prime. All right. So A prime, when I reflect over the y-axis, becomes what point? 6. What point does it become? -2, -1. Perfect. Anything so far about the basic ones before I get a little bit more tricky? All right, I'm going to go to this one right here. I'm going to go to the bottom right now before I go to this one on top. So now let's go back to 2, -1, reflect over y equals 2. So we have to start knowing what that line looks like. Y equals 2. Anytime it's y equals a number, this is going to be a horizontal line. All right. Anytime it's y equals a number, I want you to reflect over a horizontal line. So everyone go to 2 on the y-axis. Horizontal line going through 2. So this is what I'm asking you guys to reflect over right here. So if it's y equals a number, you're reflecting over a horizontal line. All right. Rule doesn't change. Distance doesn't change. How many units away is A from my line y equals 2 now? Count. How many units away is it? Count it up for me. 4. 3 units. Hey, everyone. 1, 2, 3. So make sure you're going 3 units. 1, 2, 3 in the opposite direction. And that's where A prime is. And that's going to be A prime for that one. What's that new coordinate? 3? 2, 5. All right. Oh, sorry, I wrote it in the wrong spot. It's not up here, but real quick, before I go on to this last one, which is a little special, let's say it's R reflection over X equals 3. What type of line do you think I'm reflecting over now? Vertical line. Okay, X equals is a vertical, Y equals a number is a horizontal line. All good? Before I get to this special one. All right, I'm going to clear all this out real quick because I can. 2, -1. All right, so going up to the top right, reflecting over the line y equals x. This is a special one because this is one we are not going to count. We're just going to know what the rule is. I just want to show you on the calculator what that line looks like. Get that out of there. Get that out of there. Okay, y equals x. That's the line I want you to reflect over. And there's no counting when it's a diagonal line. You can only count if you're reflecting over horizontal and vertical lines. So how do I reflect over that line? Well, it's got to be somewhere over here, right? I'm just going to have you guys remember the rule. Okay, I'm just going to have you remember the rule. There's no counting when it's a diagonal line. The rule, flip the x and y axis. Flip the x and y coordinate. That's what I'm going to have you do. So anytime you reflect over that line, y equals x, you simply flip them. Don't touch the sign, flip them. It's kind of like your y equals your x equals your y. All right. So if I take 2, -1, what's A prime going to become now? If I just flip my coordinates, what's my new coordinate A prime? 12? Just take 2, -1, flip them. Okay, now you're changing the signs on me. I just want you to flip the x and the y. Oh. That's all I want you to do. I'm glad you're making this mistake too, Rachel. Go ahead, flip them. That's it. Yep. -1 becomes your new x, and 2 becomes your new y. And hey, watch. You don't have to graph it, but I'll graph it up here. -1, 2. Look at that. Definitely flipped over the line. Okay, so for y equals x, remember the rule, flip x and y. Questions? Okay, that's great that you can flip points over lines, but I'm really more concerned, how about a big triangle? Can you do a whole triangle over a line? So go ahead, graph triangle ABC. I'm asking you to reflect it over the y-axis now. So how do I reflect the whole figure? You do each point separately. All right, so go ahead right now. I'll walk around and take a look. Take each point separately, reflect it over the y. Make sure you're doing it over the y-axis. Count the distance, match it on the other side. Make sure you're calling them prime too, right? Make sure these new ones are A prime, B prime, C prime. Not bad? We're all good? Anybody, let me know here, because I don't want to go on to more complex things unless we're good with the basics. Okay, let's do it. All right, let's take point X, 0, 5. So let's grab, where's 0, 5? I did that on purpose. Where's 0, 5? Should be on the y-axis, right? Right here. Okay, here's what we just talked about. Reflected over the line, x equals 2. X equals 2. What type of line are we talking about? Vertical, yep. Vertical line going through 2, everyone. Okay, so I got this vertical line going through 2. Count it. How far is it from that line? I'm not taking anything for granted here. 8, how far is it from the line? 2 units, so everyone please go 2 units in the other direction. 1, 2, right here. Here's x prime. And what is the coordinate of x prime now? 7? 4, 5. We're good? Now, take a look at part B. Reflect x prime. Hey, we're not going back to x. We're not going back to the original. We're staying right where we are. We're staying right at 4, 5. So take that point and reflect it through y equals -3, which is what type of line? Y equals -3, that's going to be horizontal. Yep. And I did this on purpose. Ooh, I love it, love it. I run out of graph. Uh-oh, we're going to have to think a little bit, huh? We're going to have to think. How many units do I have here? 1, 2, 3, 4, 5, 6, 7, 8 units from here to here. So that means I got to go 8 units this way. Just wanted to make sure we're going to be okay if we run out of little graphs sometimes. And remember, this is y equals -3, and you're going down another 8 units. Where do we end up? Got it here for me. Come on now. 6, where do we end up?
4.
Yep, definitely 4 because the x value doesn't change. And where on the y did I go all the way down to? Good, -11. If I was at -3 and I went down 8, -3 minus 8, I'm at -11. Last thing, how should I name this point? X double prime because I performed it on x prime. All right. I always put the double on there if I performed it on the single. In all seriousness, are we all right getting that -11? You ran out of graph? Oh, well, it happens. All right. What do we got? 2 more? Yep. All right, we got a new one now. All right, so now we'll do it with the segment. We've done it with a point. We've done it with a triangle. Now let's do it with the segment. Segment FG, 3, 0 for F. So that's on the x-axis. G, 4, 3. There it is. Part A. Everyone see the symbol? I'm not going to write it out sometimes. Lowercase r, reflect over the line, y equals x. That's one where we don't count. That's where we know the rule. Hey, that's where we remember our rule. If we're reflecting over y equals x, we flip the x and the y. No counting for that line. No counting. I just remember the rule. So what's f prime going to be? And what's g prime going to be then? just flip the coordinates. Y equals X. Flip the coordinates. Here you go. 2, 7. So F.
0, 3.
Flip them. Good. 0, 3. And G prime?
4, 3. Or 3, 4.
3, 4. Flip them. Good, Kara. Yep. So 0, 3 now. 3, 4. And I'll just put it up here real quick. Remember the line this is the line, Y equals X. Looks like we flipped it right over there, right? All right, one last new line. Now reflect it. Now go back to the original FG and reflect it over Y equals negative X. Hey, take a look at my calc. Now I want you to flip over that line. No counting again. It's another memorization one. There's only 2 I'm going to have you memorize. Y equals X, and now Y equals negative X. So anytime I reflect over Y equals negative X, I'll let you guys guess. What do you think? What do you think I have to do to them? What do you think the rule is going to be I'm going to write? You're halfway there, Spence. Say what you said again.
Flip the sign.
Change signs. Yep, you're halfway there. And it's still Y equals X, right? So I'm going to have to change the sign and flip coordinates. So you're going to do it all here for Y equals negative X. Flip them and change the signs. Y equals X, I just flip them. Y equals negative X, flip them, and hey, also change the signs for me. Just make sure you're reading carefully, right? Which one am I doing this on, the original or the one I just did? Original, FG. Just read it, all right? You got to know what you're performing it on. So here we go. I'm not going to call it double prime because I'm going back to the original. So what are these new coordinates when I flip and change the sign of the originals? 13, go back to F, flip and change the signs. What do you got for me? 0, negative 3. And how about G prime? Negative 3, negative 4. Here we go. I'm going to throw them on the graph here. All good? Last thing I got to do with you? You guys find the line I reflected over. All right, I'll give you the pre-image. So I'm giving you the pre-image, triangle ABC, and I'm giving you the image, A prime, B prime, C prime. Find the line I reflected over. All right, so I got to take a look at it on a graph first. I just can't tell by looking at the coordinates. Maybe you can, but much easier to see it on a graph. And then you tell me what line I reflected over. So to get to AB, from ABC to A prime, B prime, C prime, what is the line I reflected over? Make sure you name it correctly too. And we could start using our notation, right? Reflection, lowercase r. What's going to be your subscript now? What will be my subscript here? What line am I reflecting over? 8. Whoa. Is it vertical or horizontal? Okay, it's definitely vertical. So it's got to start out with x. Yep, you're off the hook now. It's got to start out with x because it's a vertical line right here. And what is that vertical line? X equals 10. There you go. Questions? All right. What I wanted to tell you, graphing's not optional. If the problem in the book says graph, we graph. I got slices here if you want to just do it on a full sheet of graph paper. All right, I got some slices up here, and you got plenty in the back if you don't have your own. So no excuses here. All right, so let's get going with that. If you guys want your own paper to do it on, that's fine, or you can use the ones I provided in the back of the packet. I'm not a butler.
No, this is my packet.
Oh, it is?
Yeah.
Sorry. I was like, kid wants me to hand him graph paper? Get out of town. Break your wrist before I do that.